Hi friends, I hope you all have enjoyed my first session on Pydantic, where I have explained why should we use Pydantic while writing Python programming and how to use Pydantic base model for data validation. In this session, I'll be discussing about field class of Pydantic package. Till now, using Pydantic base model, we are able to validate data type of each attributes and avoid incorrect model creation. But if someone provides negative age here, so here age is an integer. If I provide a negative value for this age, then it will be a negative integer. In case of Python, Python will accept that as the negative value is also an integer and there will be no error. But that we may not be want. And some informations about project we don't want to update once it is created. For an example, the name of employee, we should not be interested to change it in future. So all these things, as of now, it is vulnerable. Anyone can create the object of any employee and change the name, right? Anyone can create an object with negative age. So this is not a good thing. To handle all these type of complications, Pydantic provides us a field class. So let us work with that. So import field class. And then I'm saying that name is a sorry. Let us see one thing here. Let us test this thing. -1. So if I run this thing, you can see it is running fine. It is not throwing error message, which is not a good thing. Here we should be stopping the creation of this employee object here. So this is one thing. And if someone wants to update the thing like e dot name equal to Rahul, and then it is printing e dot get m. If we run this thing, so it is changing. So both these two things are not a good thing, right? So if we want to prevent that, we will be using this field class by Pydantic. And while we are defining these attributes, we'll be using this thing field, and we can say greater than equal to 18. Sorry, this is not that. Pre-frozen equal to true. If I set frozen equal to true, then it will not be changing. Here, always saying that field equal to in field, always saying that greater than equal to 18. And that way, so just commented out this thing. So you can see that while we are creating the instance of this object, it is saying that input should be greater than equal to 18. So you can easily understand what is the problem here. So we'll be updating this thing to 18. So now if we run this, we can see it is working fine. Now we'll try to change the value of name. Now if we run this, we can say it is throwing error message. It's frozen and it is throwing error message. So this is expected. We should not be changing and not the changing the name of any instance which is already created. This is the primary value, right? That should not be changed generally. Okay. We have a few more advantages. So for an example, we want to have an auto-generated user ID for each employee. So for that, we can use this field class and we can set a callable or method as a default factory like this. ID should be, I'm saying that I'll be using UUID, that type of variable, that type of value should be here populated. So we'll be importing this thing. Let's see, give option right, UUID, and we want the callable is UUID4. So here I'm giving the default factory equal to UUID4. Now it will whenever we'll be creating an instance of a employee, and unique ID will be created by this UUID method. If I provide any value while creating by externally, then that value will be taken care of. Okay. But type of that value should be UUID type, right? The value we are providing externally. So let's see what is happening here. If we run it again, now here actually we are not seeing the impact of it. If we just generate a edict equal to e dot model dump, and if we print that edict, then we can see the output of this default factory. See, you can say we have an ID equal to UUID type object, right? It's an instance of UUID. And this value is actually generated by UUID 4, which has been marked as default factory for this field. Okay, great. At the very beginning of the session, I have mentioned that the Pydantic can validate a simple string integer to a complex data type, right? So here, I'll be setting this tip equal to department. So, and I'm defining this department as a class here, right? So now I'll be checking that if it is following this department. Now, okay. Now Pydantic will validate whatever input we are providing, if it is a department or not. That validation is also been done by Pydantic. So here I have given development, which is actually one of these value. But if we key this so devel, and if we run this, we can see we are throwing error message. It is throwing error message. It is Pydantic. What is this? Unable to generate Pydantic core. It's my bad. I should have inherited enum here. This is the enum. So you have to input this enum here. So that way you have to fix this. Now if we run this, now you can see it is showing that the input should be either development, testing, or agent, right? So this is a type enum and input value is devel. We have provided input value is devel, and this is a string type input. This is not a part of anyone, right? So this type of validation is also done. So we can create any type of class, any type of enum when we know that these are the fixed value should be provided as an input of this of a particular attribute. We can create this type of enum class, and we can do the data validation using Pydantic, right? So this is one thing can do. Okay. Also here I have given devel in place. If I give development, it should be working as per the message. Error message is talking about, right? Now it's working fine. Development, but this type is actually department. So we can use this way, which is actually the best way to provide department dot name. Sorry, department dot name. Why? Department dot dev. So if I run this thing, so this is the best way because use as it is a department type, and if I type this department class, and then we'll be getting what are the options available for this department class, right? So that way it will be easier for me to provide any input value. This is the this thing one. And yes, one more thing is very important that we have shown you while we are installing the Pydantic using dependency, that is email string. Let us test that email string also. So for an example here in employee, we have an email ID and the type I am giving email str, and I'm importing email str. Now, if I provide the email value as anything other than email, so on the does, if I do this and if I run it, it should throw error message because it's not a valid email. It will surely throw that email, okay, and it's not a valid email. The value is not a valid email, right? So if we just correct that, c.com, so I hope it should be working fine. I can say it is talking about that. Yes, my email input is following the correct valid format of email ID. Right? So these are the few most important advantage of using this Pydantic and field. Next, we will be going to field validator method and model validator method, which are not being covered by this base model and the feed class that can be handled by field validator and model validator methods. I hope it was helpful. See you again in the next session.